In California, it's an all-too-common sight. Wildfires raging through neighborhoods, destroying everything in their path. And while most flee, this team flies straight toward the blaze.
We've had the opportunity to sample, I think, about 15 flights of wildfire smoke now. So we go out and measure the pollution to see what sort of trace gases are emitted by the wildfires. Some of the fires that we've been sampling, we've actually found that the pollution from yesterday or the day before can hang around and be recirculated and come back. So we've been surprised to see how long that air can be identified and sort of trapped in the area.
Laura Arachi from NASA Ames leads this brave team of atmospheric scientists. Their main tool, a fighter jet turned in-flight science lab. It's called the AJAX project.
The acronym AJAX stands for Alpha Jet Atmospheric Experiment. And we measure trace gases that are in the Earth's atmosphere from an aircraft that's based here at Moffett Field. We study air pollution and also the smoke that comes from wildfires. In the summertime, it can be really bad in the Central Valley here in California.
When wildfires aren't rampant, they use their Alpha Jet to study other kinds of atmospheric pollution. Today, they're gearing up for a unique flight.
The Sentinel-5P satellite has just launched, and we're really excited to support an instrument called TROPOMI that's going to measure all sorts of gases in our atmosphere over the whole globe.
The Sentinel-5P is an Earth observation satellite developed by the European Space Agency. It monitors air pollution over the entire planet every day. By flying under it, the AJAX team can help make sure it's collecting the best data possible.
It's only been circling the Earth for a few months now, so we're trying to fly underneath that to see if we can give a good comparison point for the satellite. They measure downward, we measure upward, and we can see if those numbers actually compare really well. So it gives some strength to the numbers that they're seeing.
The plane itself is, I guess you can't say this about a fighter jet, but the plane itself is super cute. This thing is a fighter jet, so it was designed to be really robust. It can carry a ton of weight. Today, we're going to be getting ready, calibrating the instruments, making sure everything's operating properly before we seal up the wing pods and get them onto the aircraft. So inside this sensor pod, we have an instrument that measures formaldehyde. And formaldehyde is one of the decomposition products of a lot of the chemicals in the atmosphere. So when we fly and measure that air, we can see sort of the history of the pollution of that air. The pod behind me contains a carbon dioxide and methane sensor, and also a three-dimensional wind measurement. Most of the sensors that we use light to sample the air. And by looking at what light is missing or added, you can tell what kind of molecules were in the air.
Tech ready? It's all hands on deck, moving everything from the lab to the hangar.
Flight days are really neat. You know, we always say we're in mission mode. It's fast-paced and it's exciting, and it kind of keeps everybody on your toes, and it's a really nice break from staring at a computer screen all day long.
Today looks like a pretty good day to fly. We're trying to time our arrival so that we're there at the same time that the satellite goes overhead. So right now we're hooking up the power, so the instruments will take their power from the aircraft. On a flight day, we prepare all the instruments in advance, everything's calibrated and ready to go. It's like 100 feet from sea level and much flatter.
Okay.
Caroline will be taking her first flight. She's a recent addition to our team. She's a postdoctoral fellow with the NASA postdoc program. So she'll be in the back seat for the first time, and we're really excited.
It's gonna be weird when it closes, but yeah, pretty cool. I'm gonna be turning on the instruments, keeping track of what altitudes we're at when we're making it measurements, and enjoying the view. Yeah.
Taking front seat is pilot Rob Simone.
In a previous life, I flew in the military. I flew for the U.S. Navy. It's great for me because, you know, the military said you can't fly fighters anymore because you're getting too old, and now I get to fly this, so it's great.
Today's flight plan will take them up to Northern California.
When they leave here, they're going to head north, up sort of west of Sacramento, and they're going to take a vertical profile there. And then they're going to go further north and then take a second vertical profile, and both of those will be under the track of the satellite that's going overhead. And the satellite will go overhead really quickly. It only takes a couple of seconds, but it'll take about 2 hours altogether for the plane to get back here. One thing I really like about this project is we get to help our own neighborhood. We make measurements here in California where there's some really great places to live and some really bad air quality. In addition to serving the bigger sort of NASA global satellite picture, we actually can offer our data to the local air quality managers here in California.
2 hours later, their science mission is complete.
It went really well. It's clear weather, ideal situation for us to get the data. Caroline was great all day. She had a cast iron stomach, so that was good. We did so we do a little bit of maneuvering, especially down low, can get a little bit turbulent at times, and she did really, really well.
Now they'll take the research back to the lab and start analyzing the data.
The work starts tomorrow. Today was the outdoor day, and tomorrow is back to the computer screens.